So now in this video we're going to go over this diagram here. I use a light dependent resistor. In a number of my videos, more light falls on it, it has less resistance. When it's darker, its resistance goes up. But there is slight variations if you use different resistors in the exact amount of resistance you get. But the basic properties are the same. Now we have a fixed value resistor here going to the negative supply. We have this wired up as a voltage divider. Again, I use it in a lot of my circuits. This output voltage is not intended to power a load, although in some cases it may be able to. But it will set a voltage that's a fraction of the supply voltage. Bright enough, it's going to be close to 5 volts. Dark enough, it's going to be close to 0 volts right there. But the 1000 ohm resistor is going to pull it down pretty good. So when I make those videos, I mention that you can adjust the output voltage, the sensitivity I should say, of the circuit is what I think I usually say, by adjusting the value of the low side resistor right here. So got 1K there. If I swap it for 47K, then it's going to be a lot easier to maintain a higher voltage. We're going to have to get it darker before the voltage will go down a lot with that voltage divider to get close to 0 volts right there. So now I got my multimeter here. I set it to voltage. I don't ever have to move the black probe for this meter, and the red probe stays there unless I'm measuring high current. And I have these alligator clips that I just crimped. I just used pliers to crimp them to one end of these jumpers, and I have the other end of the jumper, so there, I clipped it there. The other end of the jumper I can put to where I want to take my voltage measurement right there. Of course, this voltage for the red probe is in relationship to the voltage of the that's at the black probe right there. And I accidentally put them backwards anyways, but it don't matter what color alligator clip I put to the probe. Wasn't paying attention there, trying to make sure I stayed in shot. But any case, we have a red probe here, even though it's the alligator clip. So power is off right now. That's what that's telling me if I got a negative voltage. This power supply actually provides about 0.6 volts when it's negative 0.6 volts. When the output is turned to off. Something to be aware of if you're using this power supply. It doesn't cut the voltage completely. It can't provide a lot of current at that negative voltage, but it is something. Yeah, there you can see that we get it darker, the voltage is going to go down. We get it brighter, and yeah, this is not. I thought it would be higher than this actually, and which probably I shouldn't have. But yeah, we get it bright enough. The voltage is going to go way up there. So main thing is at this light level, we got about 1.8 volts right there. If I darken this with the lamp, there we go, about 0.9 right there. So it looks like about half right there. Now the voltage went up twice as much, so that's kind of interesting. Of course, I can turn the lamp off. This particular multimeter has a light that automatically turns on if it gets dark enough. So we got 18.9, and then what was this? Like 0.06. Okay, so those numbers shouldn't be too hard to remember. We can just yank that low side 1000 ohm resistor and drop a, now there's like infinite resistance basically to negative supply. So that's why the voltage went up. And even the 47,000 ohms right there. There you can see now at this light level we got 5 volts. Or almost 5 volts. That's probably a big reason why I use this particular value right there. I made this diagram a long time ago. So maybe at this light level I wanted close to 5 volts right there. Gonna dim the lamp, and there you can see it's not half the voltage anymore. It's just barely lower right now, and we get it dark. There we go. It's not completely dark. TV's actually on. I'll leave that on, but I'll turn the overhead light, which is energy saving light. But there you can see it went down quite a bit. I'll kind of put my hand between the TV. You can see it looks like it's going down. Any case, we're not gonna stretch this out any longer. You could see that we have a much higher voltage now at the light level because we're using this resistor, and it's not changing as rapidly as the light level changes right there. So for this voltage range, maybe this resistor would work a lot better than a 1000 ohm resistor. So now, let's say for whatever reason, we want our voltage divider voltage to go down when it is brighter instead of going up when it is brighter. We simply put the light dependent resistor on the low side right there to the negative supply, and we're going to start off with the 1000 ohm resistor right there. And of course, we got to get our multimeter, voltage meter of some kind to look at the results now. So now I got the multimeter. I'll set it to voltage there. I don't like to leave it on, drains the battery, plus it starts beeping if you let it sit too long. And I got that black for the black jumper again. This color coding doesn't matter, it's just metal on metal contact. Again, with the probe I could swap which probe is which, but in case this one's connected to the common or the ground. So this is going to be our 0 volt reference point, and this is going to be the voltage difference. So this is right now about, and that's light dependent, so it's going to change a bit. This is about 3.2 volts higher voltage than that one right there. That's what the meter is doing. So in any case, let's get back to the circuit. It's basic though, so I'll kind of throw in some other stuff. There we go, that light level. Lamp is at the brightest, no it wasn't. Okay, I thought it was brightest setting. At brightest setting, we got 3 volts right there. If we light that, we light that. And if with the lamp at the dimmest setting, 3.9, so it's going up now because we put the light dependent resistor on the low side. So the darker that it gets, the higher voltage we're going to get now. And I can turn it off, and there you can see we got like 4.9. So now we're staying close to the 5 volts, that's the 1000 ohm resistor, instead of staying close to 0 volts with the light that I'm using in this demonstration right there. And we will plug this one and do it with the 47,000 as well, like we did last time, but when the light dependent resistor was on the high side, now the light dependent resistor is on the low side. So there you can see, we were able to stay really close to 5 volts with the lamp at the brightest. Now we're really close to 0 volts. If I lower this, there you can see it's getting farther away from 0 volts. And if I turn it off, even farther away right there. But our voltage range is different because we're using a 47,000 ohm resistor. And I probably used that value in another video. I'm guessing that I used it as a voltage divider, probably on the high side. Those that voltage range looked more useful to me, although you can make any voltage range useful. But if you have a voltage range that you're set for, that is the primary thing you adjust, is the fixed value resistor when it comes to this. Now, I've done videos of this before. I'll try to find the diagram. I'll definitely do a video when I find the diagram. You can set like a maximum voltage with the light dependent resistor right there. You can adjust the resistance with a parallel resistor. That will make it so it can only get a certain high level of resistance right there. If you get like infinite resistance, you get it so dark, current can still go through the fixed value resistor. You put parallel to it. Now, if you don't want to ever be able to get 0 ohms of resistance, because if you got a parallel resistor, but you got 0 ohms of resistance with the light dependent resistor, it can go all the way down to 0 still, because that other resistor doesn't really matter anymore. There's almost a direct connection. If you want to make sure you never get to 0 ohms of resistance, you put a little resistor, whatever value you want for a minimum, in series with it right there. So it will raise the resistance by that fixed value amount. If you get this to like 1000 ohms, and then you got another 1000 ohm resistance in series, it'll be 2000 total. But you can still change this one with the light. You can get it to almost 0 if you get it bright enough, and then you'll still have that 1000 ohms if you want a minimum. But yeah, I have another diagram for that. I'll do that later. Just thought I would mention that. This is kind of a simple topic, but there's all kinds of slight little changes you can make to a circuit fragment, I meant to say, and it can change the value quite a bit. So that's stuff you should be picking up while you're learning electronics. You may never use it, and you may find the perfect time to use it. In this case, probably if you use a light dependent resistor voltage divider, you'll be trying out different value, in this case low side fixed value resistors, that side high side. But the fixed value, you got to make sure you got the right one in place. With the light dependent resistor, it's responding to light, you know, so I mean it's pretty straightforward what it's doing. That's the response to light. The sensitivity of it is the fixed value resistor, and you can even add more into it, but that's more complicated. So in any case, yeah, I rambled on pretty long here. For those of you who stuck around this long and didn't mind, thanks for sticking around. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.